Hello everyone, thanks for taking your time to be here with me today. My name is Rodrigo Rodrigues and I'm very happy to share with you this presentation that we have Data Science in Action. In this talk, we'll go over a real case study of how data science was applied in the analysis and improvement of customer satisfaction around some major issues of the Toronto Transit Commission, or TTC, related to delays and overcrowding. Through this case, you see how data science transformed public services and improved daily experiences for transit users. Thank you for your attention, and I'm looking forward to delving with this with you. Data science has become an essential tool for addressing complex large-scale issues, especially in public services like transit. Today, we are looking at a case where data science was applied to improve services at the Toronto Transit Commission, or TTC. Dr. Murtaza Haider, an academic in data science, partnered with TTC to analyze over 300,000 customer complaints gathered over a decade. This massive dataset provided a rich source of information, revealing patterns and insights that could drive significant improvements in the TTC's service quality. The goal here wasn't just to document complaints, but to convert this overwhelming data into targeted actions that would enhance the rider experience. This case exemplifies how data science goes beyond numbers, helping to resolve real public issues by turning raw data into meaningful, actionable insights. The TTC faces a lot of challenges that make it difficult to maintain high levels of customer satisfaction. Riders often report instances of delays, overcrowding, safety concerns, and lack of cleanliness. These are more isolated incidents. They represent recurring themes in the overall perceptions of the TTC's reliability and efficiency. If not addressed, customer dissatisfaction can undermine public confidence in the transit system, and it will become increasingly difficult to attract and retain riders. With over 1.6 million riders per day, the TTC really needs to address this in order to keep ridership and public confidence. This really is a great example of using data to understand and proactively address these recurrent service challenges. This entailed an organized approach to handling the vast data relating to complaints received by the TTC through emails, phone calls, and online feedback channels over a 10-year period, producing a dataset of more than 300,000 records. This was followed by a comprehensive categorization process, where each record of a complaint was sorted by topic and sentiment, hence showing very clearly the most frequent problems affecting customer satisfaction. This phase was one of the biggest challenges, guaranteeing that data was properly categorized so such categorization could provide actionable patterns through analysis. It gives transit authorities a basis for prioritizing improvements, helping in the development of a customer-centered approach to public transit, planning based on this understanding of the complaints at this scale. A structured data science approach was needed to address the TTC complaints. First, by data pre-processing that included cleaning the data and classifying the complaints into three types: delay, customer service, or station cleanliness. Setting the data to a consistent labeling scheme allowed for a valid and feasible analysis to be completed. To that, it applied statistical analysis and sentiment analysis. These techniques enabled Dr. Hader's team to follow trends in complaints over time and gauge public opinion about certain problems. The team could give more specific insights by identifying exactly when and where dissatisfaction peaks. Lastly, machine learning models were used to get predictive insights. They allowed the TTC to forecast areas of dissatisfaction and proactively address them. The kind of predictive power that is crucial for any public service organization aiming to drive data-driven decisions that resonate with users. Analysis showed several key things in the complaints data. First, the most common types of complaints collected were about delays, cleanliness, and overcrowding. These are perennial problems with a big impact on customer satisfaction. These flag the areas in which targeted improvement would yield significant dividends in public perception. Further analysis showed seasonal and time-based patterns in the complaints. Issues were particularly pronounced during peak rush hours and the winter months when harsh weather often exacerbates delays and impacts station cleanliness. By recognizing these patterns, the TTC can now better plan their resources to address issues when they are likely to occur. Sentiment analysis, on the other hand, provided a further breakdown of the drivers of dissatisfaction, which helped the TTC better understand the priorities of customers by identifying the exact areas where riders felt underserved. This analysis provides a roadmap for targeted service improvements. From these insights, various actionable steps were recommended to the TTC. First, improving station cleanliness during peak hours could directly address one of the most common complaints. Since the focus of cleaning is done during the time when stations are really crowded, the TTC can make a difference in customer experience. Next, increasing the frequency of trains during the rush hours will help to reduce overcrowding and make rides more comfortable and efficient for the riders. Adjusting schedules to provide extra service when it's needed most is a proven way to boost satisfaction. And lastly, predictive maintenance was suggested as a proactive measure, especially during winter months. Delays are more frequent in bad weather, but predicting maintenance needs ahead of time will help the TTC reduce downtime and improve reliability year-round. Together, these recommendations provide a clear path toward enhancing the rider experience through data-driven changes. Looking at the TTC case study, we have a powerful example of how data science can knit together public needs with effective service improvements. Dr. Rader and his team were able to analyze the TTC's complaint data and drill down into the core issues passengers face every day, from overcrowding to service delays. That helped the TTC pinpoint exactly where and how improvements were needed. This approach goes beyond the traditional way of responding to complaints. It transforms individual issues into insights that can create systemic changes. What is remarkable here is that data science provides a structured, evidence-based way to manage public sector challenges. Instead of assumptions or sporadic feedback, public service organizations can now use data-driven strategies to channel resources where they matter the most, like the TTC. This proactive problem-solving model does not simply react to issues after they arise, but enables anticipation and mitigation before they impact the public at a large scale. Such continuous data analysis support the mindset of continuing improvement. As data piles up, TTC and like can continue to tune their approaches, changing their operations in respect of evolving expectations from riders and changing urban dynamics. This adaptability is key because public services have to be responsive and relevant to a world in flux. Lastly, by using data science, public agencies will be able to acquire much more efficiency, ensure greater public confidence, and set new standards in accountability and transparency. All in all, data science can redefine the landscape of public service. It helps organizations like the TTC turn data into action and make smarter, more informed decisions directly attuned to the community's needs, building a foundation for continued improvement and public satisfaction. I hope you liked this presentation. Thank you very much.